Welcome to this wonderful presentation. This is Patricia of Department of Mathematics from Immaculate College, Parliament. The moment we hear the word mathematics, we remember our childhood days because we studied mathematics right from the KG level to, till your high school, right? So we all need mathematics in our day-to-day life, and we also use numbers, right, in our life, right? So when we buy anything or when we measure anything, we use numbers. So actually numbers and symbols are the basic of mathematics. Maths is a science of numbers and symbols actually. So to operate the numbers, we use many operators, right? So there are many operators, and the four basic operators are addition, subtraction, multiplication and division. Okay, so here we all know these basic operations, and let us concentrate on this division, right? So when we use when you divide a number by another number, right? For example, if we take if we divide 10 by 2, it means we have to divide the number by 2. I mean 2 to we have to keep at this 2, right? So we can easily say there are 5 2's in the 10, and therefore we can divide it and we can have the remainder is 0. Let us see another here example. So 9 is divided by 2 and we get a remainder is 1. So here 9 is said to be dividend and 2 is a divisor and 1 is a remainder. Okay, and 4 is a quotient. So let us forget this quotient and concentrate on this remainder. Now we are going to see a operation called modulo operation, and here so when 9 is divided by 2, the remainder is 1, right? So let us see some examples. So we can write in this way by using modulo, that is 9 is divided by 2, we get the remainder 1, and we can say this 9 modulo 2 is 1. So when we say this 9 modulo 2 is 1, and see another example, when sum 5 is divided by 3, the remainder is 2. So 5 modulo 3 is 2. And similarly 17 modulo 9 is 8. And see another example, 8 modulo 2 is 0, because when 8 is divided by 2, we get the remainder is 0. So 8 modulo 2 is 0. And 25 modulo 7 is, we know this answer as 4. And 8 modulo 5 is 3. We all know this. So now 72 modulo 35. So 72 divided by 35, the remainder is 2. So 72 modulo 35 is 2. Now we are going to see this main topic, cryptography. Yeah, cryptography is nothing but it is a science of secret message or a hidden message. So it is nothing but we always need some secret or privacy when we send messages to a person, right? So I mean to a person who is very close to us, right? So in early days, I mean when God created men, so after they got developed, so they became rulers. A man became rulers, and the ruler wanted to conquer all the neighboring countries or kingdom or territory, whatever we can say, right? So he, in order to conquer in the war, so he needed the secret of the enemy's army. So what he do, he set a man called spy who collect all the confidential matters of an enemy country, and he sent it to his king. So that king got all the military and army and their strategies, and he will plan according to their strategies, and he will finally win the war, right? So this is a main strategy who were the great rulers did, right? So now, so in this way, the spy, what the spy do, he just get the message and he'll send the message to the king. So in between, right, on the way, the spy send the message to the king. The message should not be revealed to anyone else, right? So they followed, in that case, a method has been created or developed. It's called cryptography. So in cryptography, we see two main components. So one is encryption, another one is decryption. So let us see what is meant by encryption. Encryption is nothing but, so the spy, the person spy, right? So he sends a message, right? So he knows some message, so that will be in a readable format and it can be understood also, right? So that message will be transformed into unreadable format, so that message cannot be read and understandable, and that format is called ciphertext. So a plain message will be transformed into ciphertext by the process or by using encryption. So encryption, and you will get the ciphertext. So the king will get the ciphertext. So what he has to do, he has to get back the original message. So what he will do is, he will again transform the ciphertext to plain text, and that is nothing but decryption. So ciphertext will be transformed to plain text by using this decryption. So encryption is nothing but plain text which is in the readable form, I mean original message which is in the readable format and which is understandable, right? So that will be transformed into ciphertext, that is called encryption, and decryption is nothing but ciphertext will be transformed into plain text. Okay, and this is your decryption. So now we are going to see so in the early medieval period, I mean in the ages of ancient civilization, so men has been keep on developing their countries, right? They were keep on developing their countries boundary, right? So in that case, the first found cryptography tool is called Skytail, and this is nothing but Skytail, and it has been used by the Spartans, and those military army were ferocious, and they have kept on conquering all the kingdom and territory they visited. So by using this tool, right? So in their period, the Skytail has been developed, and now this famous Roman emperor Julius Caesar, right? So he developed a cipher method called Caesar's cipher, which has been used by him to conquer the enemy countries. And so what does the Caesar cipher does, right? So the letter D will be, so the letter A will be written as D, and B will be written as E, and C will be written as F, and D will be written as G, and so on, right? So in this way, he just transformed the original message into the ciphertext, so that we cannot able to understand what is the message written on the paper or whatever else, right? The parchment or anything, right? So let us see an example how the Caesar has transformed the original message into ciphertext and he decrypted into original message. And this is the one of the Caesar cipher's tool, and I mean a 2D diagram, and here it is. The tool is here. It is. So by setting the key, he will. So one disk is, there are two disks, right? One is movable, another is immovable, right? So let us see an example. Okay. So I have taken this A. So if your plain text contains D, that D will be changed as G, and if your original message has H, that will be changed to L. Okay, in that way, I'm going to transform a ciphertext. I'm going to get a ciphertext for the message. So let us consider the message that hello, right? Hello is a plain text. I mean the original message, which is readable, and we can also understand, right? So this is the plain text. Now we are going to get the ciphertext. So for H the ciphertext is K, right? Okay. So for H we have here K, and the next letter is E, and the ciphertext is H, and so we will H will be replaced for E, and L, and for the ciphertext is O, and O comes twice because we have L twice, right? So next letter is O, and for this O we have corresponding ciphertext is R and R. So we have here KHOOR. Only we can spell it, we cannot pronounce the word because it is not in the readable format, right? It doesn't have any meaning. Yes, of course, right? So this is called ciphertext. So the ciphertext doesn't have any meaning because it's just a ciphertext because it has been transformed, right? Okay, so now this ciphertext cannot be read by anyone and cannot be understood by anyone, so that the message can be easily passed to the king. Okay, so now the king will decipher this KHOOR to the original message. So let us see that. Okay, so now we're going to see the decryption. Okay, so before that, let us see another example. For world, we have Z, right? And for next to for O, we have R. And for R, we have U. And for L, we have O. And for D, we have G, right? So the world will be enciphered by ZROUG, right? And similarly, college will become FROOHKH, right? So now, so in this encryption, we have plain text and ciphertext, right? So as as Caesar followed this method, so soon after what happened, so the enemy came to find that he is following such technique, right? So they can easily now after some trials they easily understood that okay, D is replaced by A and so on, right? So they found his technique. So he wanted to change the technique, and so he just found a letter called key, method called key. So key is nothing but any number from 1 to 26, because the English alphabets are 26, right? From A to Z we have 26 alphabets, and so he set the key from 1 to 6. So such a way that if he set the key as 4, if he set the key as 4, so then we will have this 1, 2, 3, 4. This A will be for E. A will be replaced by E. B will be replaced by F. Now here this key is 3 because 1, 2, 3. After skipping 3 letters, A will be replaced by D. B will be replaced by E. If the key is 4. In case, for example, I am saying. So you have here, if the key is 4, 1, 2, 3, 4. 4 letters will be skipped and they will start from E. So A will be replaced by E and B will be replaced by F and so on, right? So in that case, he said a key, right? And he's formulated a formula that is E equal to P plus K, where K is nothing but key and P is nothing but plain text and C is nothing but ciphertext. So here we set the K equal to 3. So I will skip A, B, C and I'll move on to D, right? As we did before, right? The before method is K for the before method, the key is 3 equal to 3. Okay. Okay, so this is the key for us. Now the message is attack dawn. Okay, I'm going to change this to ciphertext. So to do this, we need to change all the alphabets to numbers. So starting from A to 0, B to 1, C to 2, and similarly Z to 25. Okay. Now for ATTACK, attack dawn, I have the numerical value for A as 0 and T it is 19, and for again T it is 19, and for A it is 0, and for C it is 2, and for K it is 10, and for D it is 3, and for A it is 0, and for W it is 22, and for N it is 30, right? So these are the numerical values of the given original message. So now we are going to transform this to ciphertext, right? By using this formula, P is P plus K, C equal to P, where C is the cipher. We are going to find a C. We are going to find a C. So we need to do this operation, P plus K. We need to add both, and then we are going to take modulo 26. And so P value is nothing but plain text value, which is nothing but 0, 19, 19, and so on. And we are going to add this K equal to 3, and we are going to add 3 to all these numbers, and then we are going to take modulus, right? So let's see in the next page. So now we are going to have this P and P plus 2. So just I added 3 to all the numbers of the original message. Now we are going to take modulo 26. So what the modulo operation is, we divide the number and we take the remainder, right? So here all the numbers are below 26, and there is no meaning of taking modulo 26, but anyway, after taking modulo 26, right, this will be the number. Again 322 will be there, and the following letters are the corresponding alphabet. That is, for 3 we have D, and for 22 it is W, and for 22 again it is W, and for 3 it is D, we know this, and for 5 it is F, and for 13 it is N, and so on, right? So actually this is an example, right? Suppose if we get here 27 here, P plus 3, we have any is 27, then if we take modulo we will get the remainder 1, then we can write here 1 as, right? If it is 27 I can write 1, if it is 30 I can write, taking modulo you will get 4, and then you will write the corresponding alphabetic letter, right? But since there is no number more than 26 or 26, right, or equal to 26, we just writing the corresponding alphabetic letter, okay? So the ciphertext is D, W, W, D, F, N, G, D, Z, Q. So which is very difficult to pronounce, right? Because it is not in readable format, and we cannot understand this, right? Okay. So this is ciphertext. Now we will decipher this. So what we did actually, to find a C, we just add 3 to this P, I mean plain text. Now we are going to find this P. So we are going to find P, and we have now the ciphertext D, W, D, F, N, G, D, Z, Q, and so take this 3 to here, so you get C minus 3, right? So it is P plus K, and so the description will be C minus K, right? So this is a ciphertext and its corresponding numerical value. Then I have to subtract 3. If I subtract 3, these are the numbers, and then taking modulo 26, there is no number greater than or equal to 26. So I'll write directly the alphabetic letter corresponding to these numerical, numbers, right? So for 0 it is A, and for 19 it is T, and so on. So we got the original message called the tacton, and the ciphertext, we know this, right? Okay. So while the cryptography has been developed in this way in the medieval era, right? Many rulers were there, and the simpler monarch, diplomats, and military commanders, right? They found this Caesar text were it has a very complicated one, and we need more manual powers to encipher or decipher message or ciphertext. So they found an alternative method called a transposition cipher. Transposition cipher is nothing but just changing their position of a original message. They found a ciphertext, right? Let us see an example. It is very interesting. So the text is, plain text is meet me tomorrow, And so what they're going to do, they are going to just change the position of each letter of this plain text. So just changing the position, see how it has been done. See long, right? So MEET, meet, ME, me, TOMORROW. So tomorrow, meet me tomorrow has been put in this position, right? So that we got two words, right? MEMTMRO and ETEWORW, and we got two words and which does not have any meaning and we cannot understand, right? So the first one is MEMTMRO and the second one is ETEWORW. And the ciphertext is now has been found successfully by using transposition cipher, right? And similar way we can easily decipher it by writing in the same position. We can get the original message, right? So as the years passes by, in the Renaissance and early modern era, right? So what they did actually, they just make this transposition cipher as a old one, and they just wanted to do some changes in the Caesar ciphertext, okay, by changing the key meaning, right? So in the early Caesar ciphertext, we just has this k equal to 3, right? And the changes made by two notable figures called Leon Battista Alberti and Blaise de Vigenère. And what it changes, and the method is called Vigenère cipher, and the method is called was also called polyalphabetic substitution cipher. And they said that key as keyword or a phrase. So the key may be in the previous Caesar ciphertext, k equal to 5 or k equal to 2, whatever it is, the key value will be ranges from 0 to 25, right? Sorry, 1 to 25, 26. So here Vigenère, Leon Battista and Blaise de Vigenère set the key as some word or a phrase. So we can set a key. For example, hello may be the keyword, right? Or some phrase, it may be of anything. I love India, right? I love my country, in such a way that the phrase will be the key, okay? So the key will be known to the sender and the receiver, and by using the key, the sender will change the plain text to ciphertext, right? And similarly, the receiver will transform the ciphertext to original message by using this key. So the key should be definitely known to the sender and the receiver, right? And they just make it possible by meeting in persons, right? So now see, we see an example here, and this is a very most secured, this is considered as the most secured method in that era. And let us see an example. So I'm going to have an example that plain text as math is 1, okay? So, and my key is a keyword only, it is not a phrase, JIM. So how I'm going to use this key? Simply I'm going to take the numerical value of JIM. So the numerical value for J is 9 and numerical value for I is 8 and for it is 12. So 9, 8, 12 will be the key. And now my plain text is math is 1, and the corresponding numbers has been written here, which is considered as P because P is a plain text. Now the key has been repeated until we write this original message, right? So the length will, there is no limit for this key length. So as far as the plain text goes, this key JIM will be repeated. I mean 9812, 9812, 9812 will be repeated. But as also there is no limit or a condition that it should be finished. I mean, like suppose if I have another example N, right? For example, if I have another letter for N, and so here J will be repeated and the corresponding letter 9 will be repeated. Okay. So the key will be 9812, 9812, 9812, 9. In the case of if we have n nearby another n, right? So for example, I'm saying, suppose if I have some x, the key 9 will be repeated. Okay, so in that way, now what we are going to say, we are going to follow the same formula, that is p plus k, right? We are going to add this p, this 12 plus 9, it is 21, 0 plus 8, 19 plus 12. And so if we add, we will get this, right? So 21, 8, 31 and so on. Now we have the numbers. Two numbers are greater than or equal to 26. So now we are going to take modulo. So 20 will be 21, 8 will be 8. For 31, if we take modulus, we know that when we take modulo, we have to write the remainder. And so the remainder is 5. And for 30, the remainder is 4. And for 28, the remainder is 2. Okay. And we are writing the corresponding letter, alphabetic letter, that is V, I, F, W, Q, E, O, C, Z. And so the ciphertext is V, I, F. Okay, right. So which is not in the readable format, we know that, right? So similarly, we can easily decipher it. Okay. So for deciphering, the key will be found by 26 minus 9, because we took modulus 26 and so we are subtracting 26, right? So we are subtracting 9 from the 26. So 17, 18, 14 will be repeated as a key and ciphertext, and 17, 18, 14 is repeated here, and we did here and addition and the taking modulus, again writing the corresponding letters. So the original message is got by using this decryption math is, right? Okay.